Alright, so I wasn't able to get to these problems in my other classes, and that's why I'm going to get to them with you, because we do have time, and I'm going to write them out, and you'll have the answers to look at for your homework and whatnot at home, okay? This will be part 3. Here we go. 15xy is underneath the square root, and we're going to divide by 10xy cubed underneath the square root, and a 3 is multiplied outside. Now look, some of you are probably thinking right now, is this 3 like 3 times this? Or is it the cubed root? Where does this 3 belong? Okay, so if you are not clear, imagine what I will feel when I grade your quizzes if you don't write it legible enough to where I know what you're talking about. Okay, this is not the cubed root. Okay. What do you know for sure that we have to do to simplify this? We have to rationalize the denominator. Okay, get rid of that denominator. Now here's your choice. You can multiply right now by a form of 1, or you can try to simplify what you see right now first, and then rationalize the leftover piece. Which one is easier? It depends on you. It depends on your strengths. Okay? I would look at this, and up top I see 3 and 5. On the bottom I see 2 and 5. I could combine it to one huge fraction, but already you're kind of like thinking to yourself, man, that's a lot. That's a little bit right now. So let's go immediately to multiply by a form of 1, which is the entire square root piece. Notice I didn't multiply by 3. I don't need that 3. That's not in square root. I just need to rationalize the pieces that are in square root. And this is a form of 1 that's going to make it happen. Yes?
So will you always do it by like the denominator?
Yes, always the denominator, yeah. Yeah.
If you had a cube root, would you have to multiply it 3 times?
You'd have to multiply with a cube root, yeah. That's a really good question. If it was a cube root, we'd have to multiply it by, actually, hold up a bit. He's saying if you had a cubed root, would you have to multiply it 3 times? In other words, you'd have to multiply it by itself 3 different times. And he's exactly right. But let's not go there. You're way ahead right now. Slow down. All right. So guys, what will happen to those 2 pieces? That was awesome. I'm going to give them points for that. Because if it was cube root, there would need to be 3 of them. Okay? If I multiply these 2 pieces together, think about what we did before. 10xy cubed. That's it. That's all what's left. So 10xy cubed times this 3. Y'all with me? So it's the same as just 30xy cubed in the denominator. You got rid of the square root. It's rationalized. And now you just got to put all this 2 together with the rules that you've learned. This is the same as putting it all underneath the same house with 15 times 10 times x. You see what I'm doing? Times y times y cubed.
We just go ahead and simplify that instead of writing it 15 times 10 times x times y cubed. We just go ahead and simplify that for everyone.
Simplify it to what?
150x squared y to the 4th.
Okay, so 150 x squared y to the 4th. How many x's come out? No, careful. How many x's come out? 1. Okay. How many y's come out? 2. So y squared. The reason why I kept it as 15 and 10 is because you can, well, you could probably see it still. What would come out with 150? So 50, 150, isn't it the same as 25 times what?
6.
Times 6. 6 quarters in your pocket is $1.50. Okay? So this 5 will come out because 25 square rooted is 5. Right? But the 6 stays in. 6
Times
times 25.
Oh, okay,
So
sorry.
it'd just be 5x y squared square of 6.
We just have to reduce now, right? What's 5 and 30 reduced to?
1/6.
1/6. What are the x's reduced to? Not 0. That's a good mistake. 1. Because this is a form of 1 cancellation, which is helpful for the rest of this year. You'll see it coming. There's 2 y's up top. There's 3 y's on the bottom. Who wins? The bottom one. By how much? 1. And then you're left with root 6.
So would that be considered rationalizing?
Okay, so this whole thing was considered rationalizing and reducing. Okay? Again, all we're doing is multiplication and by groupings. That's it. Okay? You have one more problem and then we will call it a day. Your last problem is the most involved. Here we go. 5 plus 2 root 2. Some of you that are sitting back and just watching, that's good if you're getting it. But if you don't plan on memorizing it after you leave, you need to write this down. Because this is easy to forget. Alright. Here's my example. And I want to simplify it. Let me ask you. Can I cancel this 4 and that 2? Yes or no? No. For 2 reasons. 1, they're not underneath the same root. They're not underneath the same house, if you will. Okay? What's the other reason? It's not all glued with multiplication. There's addition in between, and I cannot cancel in between addition. Let me give you an easy problem. If I said 1 plus 4 divided by 2, that's 2.5 or 5 halves. If you cancel this, thinking that this would become 2 over 1, that's not 2.5. You can't cancel between addition and subtraction. Okay? Alright, so 5 plus 2 root 2 over 4 minus root 5. I'm going to reduce, or I'm going to rationalize the denominator, but it looks a little bit different, okay? I'm going to multiply by a form of 1. Okay, and this form of 1 is called multiply by the conjugate. Just a fancy word of saying it's a piece that will not only get rid of this square root, but will simplify the bottom as well. Okay, you ready? Here we go. Some of you might be thinking, ooh, multiply by that. That won't work. Because that's going to create 4 root 5 minus 25, minus 5 on the bottom. So it has to be a little bit more. It will be including the whole bottom. The only difference is your goal is to do the opposite sign. Because guess what I'm looking at right now? Not 0, but a difference of squares. Nice. Difference of squares. And a difference of squares, look what happens. 4 minus root 5. 4 plus root 5. Shh. Again, this is what you're doing next time we see each other anyway, so get a little practice. We get 16. What's the outside term?
4 minus root 5.
Positive 4 root 5. What's the inside terms? Negative 4 root 5. Look at that. Those go to 0. And then what's the last going to give me? negative 5. So all of that denominator just turned into, simplified, to 11.
That's crazy.
No more square root. If it was 4 plus root 5, you'd multiply by 4 minus on both. So you can find that difference of squares. Okay? Now, that's for the denominator. Do the denominator first, then go up top, and then mess with all that stuff. Here we go. So 5 plus 2 root 2, 4 plus root 5. I'm distributing the top right now, guys. Okay? So we are working on right now, the bottom was easy, we got 11. We're doing this now. Guys, am I allowed to have square roots in the numerator? Yes, all day I can. I just can't have them in the denominator. Okay, what is that? 20. What is this? 5 root 5. What is that? 8 root 2. And then what is, careful, think of your rules. 2 root 10.
Yeah, wasn't
It's a root 5 plus 2 root.
Oh, did I miss the root 5?
Yes.
Oh, why didn't I write it?
Are you asking me? Why did you
How do you know it's a root 5?
Oh, never mind.
Because that's what the thing
Never
said.
mind.
Oh, you're going off of your, okay. Don't go off of that. Go off of what I'm showing you right now. You're going off of what you thought I was doing over there. Yeah. Let's keep going here. So can I add this with that? No, I can't. I can't even add. So guys, if I had 3 root 2 plus 5 root 2 plus 8 root 2, could I add this to be 16 root 2s? Yeah, I can.
It's the same radical.
Same radical. It's like saying 3 pencils plus 5 pencils plus 8 pencils will give me 16 pencils. You with me? So, none of these are the same. They're all over 11. So you could write it out, your final answer. Sometimes you will not be able to group stuff together. And this could be your full answer. I know, very gross, right? Or you could have written 20 over 11 plus 5 root 5 over 11, 8 root 2 over 11,